Bismillahirrahmanirrahim. Hi viewers, in this video I shall discuss the mole concept, molar mass, molar volume, various formula, and through this formula I shall solve some numerical related to mole concept. Who is Avogadro, who presented Avogadro number. Now what is mole? Mole is the Latin word which means greater mass or huge mass. Mole is the SI unit of amount of substance. Substance and word matter exist in two forms. One is the purest form, which is called substance, and the second is impure form, which is called mixture. Example of mixture is air. Substance is the purest form of matter which have well-defined physical and chemical property. Physical property are those property which we can observe, and this property, the product which is formed, can be changed again into reactant, while in chemical property the product can't be changed again into reactant. Its composition is uniform or same throughout the world. From any source, from anywhere, if you take water molecule, its composition will be same, that is, it is formed from 2 hydrogen and 1 oxygen, and its properties also same. It is represented by small n. Definition of mole is a group of 6.023 multiplied by 10 raised to power 23. Similar thing is called 1 mole. Twelve similar things are called dozen. If we take 24 bananas, then it is equal to 2 dozen. 1 mole pencil is equal to 6.023 multiplied by 10 raised to power 23 pencil. 1 mole book is equal to 6.023 multiplied by 10 raised to power 23 book. Just like this, 1 mole hydrogen atom is equal to 6.023 multiplied by 10 raised to power 23 hydrogen atom. And 1 mole of water molecule is equal to 6.023 multiplied by 10 raised to power 23 water molecule, H2O molecule. Now what is molar mass? When we express atomic weight or molecular weight in gram, it is called molar mass. For example, if we take 18 gram of water, then it is equal to 1 mole, and it will contain 6.023 multiplied by 10 raised to power 23 water molecule. Molar mass is the mass of 1 mole of substance. The weight of 1 mole of aluminium is equal to 27 gram, and it contains 6.023 multiplied by 10 raised to power 23 aluminium atom. So if we express atomic weight of an atom or molecular weight of molecule or formula mass, which can't exist independently in nature, is called formula mass. For example, NaCl in grams, then it is equal to 1 mole. 1 mole of hydrogen atom is equal to 1.008 gram. 1.008 gram is the atomic weight of hydrogen atom, and if we take this amount, then it will contain 6.023 multiplied by 10 raised to power 23 atom of hydrogen. 1 mole of oxygen atom is equal to 16 gram. If we take 16 gram of oxygen atom, then it will contain 6.023 multiplied by 10 raised to power 23 atom of oxygen. If we take 1 mole of water, then it is equal to 18 gram of water, and it consists of 6.023 multiplied by 10 raised to power 23 molecule of water. Just like this, 1 mole of sulfuric acid is equal to 98 gram of H2SO4, and 1 mole of glucose molecule is equal to 180 gram of C6H12O6. What is Avogadro number? The number of particles present in 1 mole of substance is called Avogadro number. This was first presented by Avogadro and represented by capital Na. Its value is 6.023 multiplied by 10 raised to power 23. And this number was first determined by Italian scientist Avogadro. What is molar volume? The volume of 1 mole of all type of gases occupy 22.4 liter at STP condition. Molar volume is equal to 22.4 dm3 at STP condition. STP means standard temperature pressure. The temperature will be 273 Kelvin or 0 degree centigrade, and pressure will be 1 atmosphere. For example, this is a beaker which consists of 6.023 multiplied by 10 raised to power 23 molecule of SO2 gas, that is 1 mole of SO2 gas. It will occupy same volume 22.4 liter. This is the second beaker in which we take 1 mole of N2 gas, and it will occupy the same volume, that is 22.4 liter. This is the third beaker in which we take 1 mole of NH3 gas, and this will occupy the same volume 22.4 liter. So all these different gases, that is 1 mole of SO2, SO3, NH3 gas, occupy equal volume, that is 22.4 liter. In case of atom, for example, oxygen atom, 16 AMU and 16 gram. 16 AMU represent its atomic mass, that is the mass of single atom. 16 gram represent the molar mass of oxygen, and we call it capital GAM, gram atomic mass. That is the mass of 1 mole of oxygen, mass of 6.023 multiplied by 10 raised to power 23 atom of oxygen. In case of molecule, water, and sometimes we write 18 AMU, in some cases we write 18 gram. 18 AMU represent molecular mass, and 18 gram represent gram molecular mass. 18 AMU represent the mass of single molecule. 18 gram represent the molar mass of water molecule. Now, what formula used to calculate the number of moles? First formula is number of moles is equal to mass in gram divided by molar mass. And the second formula is used, number of moles is equal to percentage of element divided by atomic mass of element. And the third formula is number of moles is equal to number of particles divided by Avogadro's number. In case of gases, how we can calculate the number of moles? Calculate the number of moles of 67.2 liter of SO3 gas at STP condition. So for this, put the values in given formula. Number of mole is equal to the given volume divided by 22.4 and we get the number of moles, that is 67.2 divided by 22.4 is equal to 3 number of moles. We can convert grams into moles and moles into grams. Suppose calculate the number of moles in 20 grams of NaOH. This is a beaker which consists of 20 gram of NaOH. This 20 gram of NaOH is equal to how many moles of NaOH? So the formula used for this will be number of moles is equal to mass in gram divided by molar mass. So put the value in this formula. We get number of moles is equal to 20 divided by 40. So it will be equal to 0.5 moles. The second problem is how many grams are present in 0.25 mole of NaOH. This is a beaker which contains 0.25 mole of NaOH. So for this the formula used is mass in gram is equal to number of moles multiplied by molecular weight. So put the value in this formula. We get 0.25 multiplied by 40 is equal to 10 gram. Calculate the number of moles in 350 cm cube of CO2 at 273 Kelvin and 2 atmospheric pressure. So in this problem, in this numericals, the condition is not at STP. So for conversion into STP condition, we use the formula P1V1 is equal to P2V2. P1 is equal to 2 atmosphere and T1 is equal to 273 Kelvin and V1 is equal to 350 cm cube. At STP condition, P2 is equal to 1 atmosphere, T2 is equal to 273 Kelvin and V is required at STP. So number of moles is equal to V at STP divided by 22.4 liter. V2 is equal to P1 V1 multiplied by T2 divided by P2 T1. So putting value in this equation, we get 700 cm cube. For conversion of cm cube into liter, we divide it by 1000, so we get 0.7 liter. Now put this value in given formula. So number of moles is equal to 0.7 divided by 22.4 liter, and through this formula we get the number of moles at STP condition. The formula used for this numerical is V2 is equal to P1 V1 T2 divided by P2 T1. How many atoms are present in 16 gram of sulfur? The formula used is number of moles is equal to mass in gram divided by molar mass. So 16 divided by 32 is equal to 0.5 moles. Number of moles is equal to number of particles divided by Avogadro number. First we can calculate the number of moles. Then we put this value in the number of moles is equal to number of particles divided by Avogadro number. So number of particles is equal to number of moles multiplied by Avogadro number. So, 0.5 multiplied by 6.023 multiplied by 10 raised to the power 23 is equal to 3.06 multiplied by 10 raised to the power 23 sulfur atom.